to go ahead and work prime factorization really quickly off of our numbers. So we're going to use 216 to begin with, and we're going to use prime factorization to do cubed roots. So I'll teach you a technique to go through and do this. So 216 prime factorization is breaking our numbers down into our primes. So that looks like an even number. I could use 2, but I'm going to try a different technique. If I check those and add them together, they give me 9. So my divisibility rule for 9 is if the sum of the numbers, when I add them together, is divisible by 9, then the whole number is divisible by 9. So 9 will go into the sum of 216. So I know 9 is going to go into that. Now, I don't know how many times 9 will go into that number. So on my calculator, which I'll go ahead and pull one out here. Hopefully you're seeing it. I'm going to go ahead and punch in 216, and I'm going to divide that by 9. And when I do that, it gives me 24. Okay, 9 will break down to 3 times 3. Those are both prime numbers. 24 will break down to 2 times 12. Somebody else might have said 6 times 4. It doesn't matter. In the end, we'll end up with the same digits. 12 will break down to 2 times 6. And 6 breaks down to 2 times 3. Okay, so now my prime numbers, notice I circled as I went so that it's easier for me to see. Okay, so now I'm going to go ahead and I'm going to circle sets of 3 of a kind. So here's 3 2s, there's 3 of a kind. And it looks like I have a set of 3 3s also. So now for each set, I get to write that number that's inside of that set one time. So I had one set of 2s and I had one set of 3s. Okay, that's all I had. There was nothing else left over. So the cubed root of 216 is going to be 2 times 3, which equals 6. In other words, if I want to check myself, if I do 6 to the power of 3, it should give me 216 on my calculator. So 6 times, whoops, I forgot to clear my calculator, sorry. 6 times 6 times 6 gives me, why is that doing that? Gives me 216. A little complication with my calculator there. But I did end up with the 216. So my cubed root of 216 is going to be 6. All right, so let's go ahead and try another one of these. So once again, working that prime factorization. And then from there, finding our groups of 3 of a kind. Okay, so I'm going to check my divisibility rule for 9 just because then it kind of reduces the number of times that I have to divide out on one side of my factor tree. So let's see. 1 plus 7 is 8, plus 2 is 10, plus 8 is 18. Will 9 go into 18? Yes. So I'm going to use 9. Now 9 will break down to 3 times 3. Okay, I don't know how many times I would have to take 9 times to get 1,728. So I'm going to punch in 1,728, and I'm going to divide that by 9. And my other factor on that top level was 192. So 9 times 192 gave me 1,728. So now I'm going to break down my 192. And 9 plus 1 is 10, plus 2 gives me 12. So I know 3 will go into it because 3 will go into 12. Now that rule that I just used only works for 3 and 9. I can't use it for other ones. Okay, I don't know how many times 192, 3 goes into, so I'm just going to divide by 3 on my 192, and that gives me 64. Okay, 64 will break down to 8 times 8. 8 breaks down to 2 times 4. 2 is prime, so I have to make sure I circle it, and then 2 times 2 on my 4, so I'll continue that same pattern up on my other 8. 2, 4. 4 will break down to 2 times 2. Very important that as you get to your prime numbers, you circle them. Okay, so now I'm going to find sets of 3. 3 of a kind. I need 3 of a kind because I'm working cubed roots. So here's 3 of a kind. So I have a set of 3s. Here's 3 of a kind. I have a set of 2s. And here's 3 of a kind. I have another set of 2s. Okay, that's it. There's nothing else that's a prime number that's circled. So I'm going to go ahead and multiply this out. 3 times 2 is 6. Times 2, 6 times 2 is 12. So my cubed root of 1,728 equals 12. If I want to check myself, I'm going to take my calculator and I'm going to do 12 to the third power. Let me clear this. So I'm going to do 12 times 12 times 12. It should give me 1,728, and it did. So my answer on that one would just be 12, not 12 to the third power. All right, we're going to try one more here. Ooh, a big one, 3,375. So I'm looking at that like money. I see 75 in there. So I'm going to say quarters. I'm going to throw a 25 out here. Now, I don't know what I have to take 25 times, so I'm going to punch in 3,375 divided by 25 gives me 135. Okay, 25 can break down to 5 times 5. 5s are prime. All right, 135. I could use 5, but I'm also checking. I always like to check that rule for 9. So 1 plus 3 is 4 plus 5 is 9. 9 will go into this number. Okay, so on my calculator, I have 135. I'm going to hit divide by 9 to see what I would take it times, and that would be 15. So now 9 I can do 3 times 3. Those are both prime. And 15 I can do 3 times 5. All right, now I'm going to find my 3 of a kind. So let's see. Here's a set of 3s. So I get to write that down. I have a set of 3s. And it looks like I also have a set of 5s here. Doesn't matter that they're next to each other. So I'm going to say times 5. So 3 times 5 gives me 15. So my cubed root of 3,375 equals 15. To check myself on my calculator, I can do 15 times 15 times 15, and it will give me 3,375. So that's it for this lesson. This comes in very handy also for squared roots. It's just then you would do pairs of 2 or sets of 2. Good luck with this part of the lesson.